Right. All right. So that's the problem that you presented to me. It's quadratic inequality, right? So this is what it is. This is a quadratic inequality, and you're trying to graph it, right? And if you know how to graph a quadratic function or a quadratic equation, then you should be fine. Okay, so let's go through the process. And pretty much the setup here is great because what we need to do really is to graph this. Y is equal to 1 minus x squared. That's the first thing you want to do, is to graph this representation, right? 1 minus x squared. That's your first step. You set it as an equation. Then you want to graph it, right? So you want to graph y, okay, graph y is equal to 1 minus x squared, okay? All right, so if you look at this this graph, I don't know how familiar you are with the x squared term, but we know that, let me see if I can use some of the shapes here to facilitate the graphing here. Let's see if it's going to work. Last time I was using that, and okay, so let's see. Here we go. Okay, so let me see if I can use another shape here. No, I cannot see a shape that I, okay, so forget it. All right, so here, this is f of x equal to x squared, which is the f of x here is a notation for y equal x squared, right? So sometimes you may see f of x just means y. So y equal x squared is a basic parabola, right? And the basic parabola goes as follows, right? So this is how it is. And never mind it, the curve is a little bit messed up, but basically this is how a quadratic function y equal x squared looks like, right? Now, you notice that this is 1 minus x squared. The negative x squared here, that x squared, so you can view this as y is equal to negative x squared plus 1. You can view it like that. And the negative x squared graphically means that it is the reflection of the y equal x squared about the x-axis, right? So the x-axis here is the horizontal line, right? And if I say, well, graph f of x equal to negative x squared, so basically this is it. This is the reflection of this over the x-axis. So let me choose another color. Maybe I should have, I'm going to put that color here, f of x is equal to negative x squared. And the reflection will just be this, right? So I hope you understand what I mean by reflection, right? So, oh, come on. Here we go. Right? So you understand that this part right here is a reflection of this part. So this red parabola is a reflection of negative x squared. Now, the plus 1 here, right? So here, I'm sorry, I'm just going to put it as negative x squared plus 1. So the red part was reflection about the x-axis, right? And then the plus 1 here, let me use another color, like this blue, right? It would be not the reflection, but I want to use the right term I was about to say, the movement of the parabola 1 unit up or down, right? So If it's plus 1, it's going to move 1 unit up. The whole parabola is going to move 1 unit up. So that negative x squared here is going to move 1 unit up. So if it goes 1 unit up, now this vertex, right, the tip of the parabola is going to move 1 unit up, and that's it here, right? And everything else is going to move 1 unit, and that's it, right? So, and this is how it's going to look like. Come on, right? Everything else is going to move 1 unit, and this is your action. I don't know what's going on with the straight line, but okay, so this is it. So this blue thing here, right, is f of x equal to negative x squared plus 1, or f of x is equal to 1 minus x squared. Okay, so that's all we needed here, that blue part right here. Okay, and I want to use, let me go into the website here called desmos.com, right, and show you, how I created all those things here, in a neat format. And then we're going to come back and finish the graphing inequality, right? So we know that x squared, right, looks like this, right? So that's the red part. And then negative x squared looks like this. That's exactly what what we did. And then if third one, if I have 1 minus x squared, or negative x squared plus 1, this is what, this vertex here, the blue one, is going to go 1 unit, right, at 0, 1, and all the other points go up by 1 unit, right? So this is so you can see that's exactly what I did here. This one looks better, okay? So basically, this is kind of the transformation that happened from the basic x squared term to 1 minus x squared. That's a transformation. Now, we only need this here because this is what we wanted to graph. So I'm going to kind of erase those parts here. Let me see if I can. Oh, come on. Uh-oh. Okay, so let me kind of erase and recreate it. So you should know how to do it now, right? So oh, come on. I'm sorry. I don't know what's going on. Here we go. All right. And let me draw that 1 minus x squared, right? So it should be like this, right? Something like this. I'm sorry. This bothers me. Okay. So it should be something like this. Alright, so now let's talk about this statement here. Oh, I clicked this, and that's why I get the straight line, the ink shape. Anyway, all right, so I have this parabola, and now I want to know what is y when y is less or equal to, is less than 1 minus x squared. Okay, so the inequality sign tells you that you want something that is strictly less than 1 minus x squared. The y here is always the reflection of your graph, right? So for example, your graph that you see here are all the y values of 1 minus x squared, right? That's what you see here. This is y equal to 1 minus x squared, right? So you have all your independent values of x, you plug it in, and then you get the value of y in your graph, right? But I want everything that is less than 1 minus x squared. And here, because there's no equal sign, I don't even need whatever is in, I don't need this graph. So I just need to represent 1 minus x squared as the boundary. And so, therefore, I need to represent the boundary as follows, as a dotted line or a dashed line. So for example, I'm going to do this to show that the graph 1 minus x squared is not part of the solution, is not part of my graph. And that's how you show it. This is your boundary graph here, 1 minus x squared. Now, everything that is less is under this graph. And under this graph is basically everything here. Right? Everything here is less than y, which is 1 minus x squared. Makes sense. And if you want, you can test it. Why not? Right? So I can use the point 0, 0. Right? So if I test 0, 0, that means x equal to 0 and y equal to 0. So if I plug in 0 is less than 1 minus, x is equal to 0, 0 squared. Right? 0 squared is 0. So is 0 less than 1? Yeah. That's why we shaded that area. You can take any point. So let's say I'm using another point here. Let's say it's 0, negative 4, right? And I plug it in. So this is negative 4, right? And x is still 0. So it cancels out. Is negative 4 less than 1? Yeah, it is less than 1. So it is in that shader. So let's try anything on the outside. Let's say it's 0. 0 what? 2, for example, right? So y is equal to 2, and x equal to 0, right? Well, is 2 less than 1? No, it is not. That's false. That's why it's on the outside. So the 2 is greater than 1. So that's how you graph this quadratic inequality. Okay, so hopefully I answered the questions, and let me know if it helped.